Hi everybody, so 3D printers, that's enough playing, let's get some work done. We're getting to the bit that I actually want to do with 3D printers. Now, I don't know if you remember this. It was the Darwin wind turbine, and I made that out of wood with flat vents, and to be honest, it rattled worse than a skeleton in a hurricane on the Day of the Dead. You weren't going to get much sleep with that thing banging around on your roof. A friend of mine, Max Kennedy, thought exactly the same thing, and he had a look at it thinking, can we do a flapless version? And he made some models in paper. And with those paper models, he was able to show that this thing actually worked, blowing the air up through the central vent and not disturbing the string at the back with the wind flow going over it. And that was really awesome. And Max wrote to me, gave me this. I'll put a link to his original video, incidentally, at the end of this video, so jump over, give a watch, give a like, because he's done the work, not me. So he did this thing out of paper and he sent it over saying, what do you think, Rob? And I thought it was awesome, absolutely awesome. So I thought what I would do is I'd do a plastic 3D print version that we could put together and make a Darwin modified wind turbine that was flapless and so going to be silent. Well, I've gone through Tinkercad, so I jumped over to Tinkercad and designed an STL file to test the blade, and this is the design of the blade. And now what we're doing is we're printing it. So I'm printing out individual blades. They're 5 centimeters by 2 centimeters, so we can see the idea actually works by putting it together. Once we do that, of course, we can put them together in the actual program to create a rack of them, and we can see if we've got a nice rack or not. But anyway, let's get them printed. So there's my tiny example printed, and if I put 8 of them together, then I can check the angle of them, and yep, they make a complete enclosure. Now it's an octagon, okay, so that internal angle is 135 degrees. Now, Max tells me that if it has baffles on the outside, the support structure like on the outside, it operates better. He did both, and if you watch the video, you'll see the result of that. So he did both, and I've put the baffles on the outside, so the wind hits the baffle, and then it's forced up. Obviously, this is what a single ringer's like. To make a multiple ring, what I've also done with these ones is to check that they, in fact, slot on top of each other, because that would be annoying. And they do slot rather nicely on top of each other to make a stack. So having checked that, we now can have a bit more confidence that we can put these together in a rack and print a rack out. Okay, to see how I made that, we're in Tinkercad, we've got the work plane, and I always put the ruler on, because if you put the ruler on, you can tell where you are and what you're doing. Stick it on, yeah, use midpoint, there we go. Now this is a whole group of primitives you get. You get other ones if you click down on basic shapes, so these primitives are all I actually used. Start with the tube. Put the tube somewhere on there. If you've got ruler, all of this stuff will show up, which is brilliant because it means that we can change sizes simply by clicking on there and typing in our new size. We can move it with the arrows like that, or we can move it just by clicking on there and typing in the position that we want it to be. There we go, it's in the center. Now we want this, which is more or less an erase tool. If we click on that box and add that box, and we can drag the handles to change the size, or we can highlight those and change that. And equally we can change the position. Remember, we used midpoint, so if we click on that midpoint, it was -105. We click on that midpoint, it'll be that midpoint there, which is 10 from there. So 105 would be 95. And that puts it in the midpoint of there. Now if we click out there, highlight the whole lot, and group the shapes, we get only that shape left. It's only 10 millimeters high, which is a bit short, so let's make it 60 millimeters high. There we go, we've now got it 60 millimeters high. Now what I want to do is angle that a little bit. If we go to, there's heat, there you should see that angling. There it is, and there it is. We can click and hold, move down to there, As you move that, it will be 22.5 degrees. On the outside one, it's every 1 degree. Let's put it at 45 degrees. And then we've got our angled piece. Now, of course, we want the side bits to it. And for the side bits, we can use this. Put the block on there. If we're wondering how big that is, remember all you actually have to do is that, and it tells you it's 49.5 high. We want to leave a little bit at the top, so let's make this 50. So in its height, which is that one there, we'll make that 50. Its width, we only want about 3 millimeters, and its length here, we want about 40. And that gives us a side pane. If we click on that side pane now, we'll again get the rotate, there it is, and we can rotate that 22.5 degrees that way. That will give us an octagon when it comes time to do the actual octagon. Click on top of the top view. That's looking pretty. Okay, so if we click on that and we replicate it by clicking the replicate button there, Control D, or just hit that button there, it will replicate it. It's the live one. If we go here and click mirror, it'll ask us which way we want to mirror. We want to mirror it that way, and we get a duplicate mirrored at the other 22.5 degrees, and we can just slide that along until we get it into that position. And we're getting very close to what we actually want. All we need to do now is get rid of some of these bits and pieces, and of course to get rid of things we use this. So we can stick a box on there, and again we can increase that to 40, which is the one that we had before, 40, and then we can increase that to 40. And if we move that down, it will cut off this. Of course, we want to angle it again. And we want to angle it the same way that we did that at 22.5, and then we can move that in there. Check it's in the right position. It's obviously too short, so let's increase that to 50. There we go. Then we can duplicate that and we can mirror it, and this time again we want to mirror it that way and slide that one over there. Check it's in the right position. Okay, but now we can click off the workspace, highlight it, group it, and it will rid us of all of that. Now we've got these extra little bits that we don't particularly want, so we can get another box. We can make it whatever size we want. You'll see, however, it is on the ground floor, so to speak, and we want it to be 50 up because we want it to be on the top of here. You can see it's saying there it's on the ground floor right there. Let's type 50, and lo and behold it jumps up to the right height that we want it at, and then we can drag it over there. Angle it. And move it in position. You can also move it by pressing the arrows. Fantastic. And again, if we duplicate that and mirror it and then put it over that. And again we can go off, highlight and group. We're left with these extra little wing bits that we made an error with, but we can do exactly the same thing to remove those. The only other thing we really need to do is to tidy up this bottom section here. And for that, again, we can see where it is. It's at 0. Let's move it up by 15. Get another one of these boxes. Stretch it out so it covers the entire bottom of it. And then if we look at that and click on it, remember it was 15, we can lower it. There we go, now it's all cut off there. Let's raise that up a bit. There we go. And again we go out and group. Flashes red for a minute. And we get it there. Now we do that, we can see that's at 20, so let's drop that onto the bed by changing that to 0. And it's dropped on the bed. And there we go, that is my basic shape, more or less. I'll just tidy these two little wings up that I left there by mistake. Okay, and that is how I made my basic shape from the primitives available in Tinkercad. Then all we have to do is export it. When it's exported, it's fixed, and we can re-import it, and then we can just duplicate, duplicate, duplicate. So there's a single stack of 3, and it's done just by stacking those up in the drawing program, exporting it, slicing it in Cura, and then printing it. And if I blow here, it does indeed direct the air upwards, which is really cool. So the next thing's obvious. Print 8 of these and stick a PC motor on and test it, and maybe dangle some bits of red string to make sure that that octagon shape also works. But this works to direct the air coming here upwards. And we've seen previously that it won't come out of the back, so this should be a really good update on the Darwin wind turbine. But it's also something else. It shows you what can be done with the simplest tools. I mean, Tinkercad is something you're going to get hold of in about half an hour, and although it is a cut down and simplified version, you can do some great things with it, and it's going to get you up and printing and having fun and making things, which is what it's all about. 3D printing isn't about 3D printing, it's about making stuff. And that's why I like it, because it's all about making stuff. Anyway, looks like we're well on our way to updating the Darwin wind turbine, and we'll certainly keep you in touch with that, but I wanted to go through that so you could see from the ground up how I'd actually been doing it. I hope you enjoyed the video. Thank you very much for watching, and please do remember to like, subscribe and click the bell notifications.